Every year, one of the biggest logistical puzzles on the entire planet unfolds in a single city. Today, we're going to look at how some seriously cutting-edge technology, we're talking AI, quantum-inspired computing, is being developed to manage this holy journey and make it safer for millions. So, to really get a sense of the scale here, let's start with the numbers. We're talking about more than 2 million people, all heading to one place, the city of Makkah, for the Hajj pilgrimage. And here's the thing, this isn't some slow trickle of visitors spread out over a season. No, it's a massive, concentrated wave of humanity, all showing up within an incredibly short period of time. And just to make things even more complicated, these pilgrims are coming from over 180 different countries. That means you have thousands of separate groups, each with its own travel plans and schedules, all needing to perform a very precise set of rituals in a very, very tight space. So you put all that together, the sheer number of people, how packed in they are, the tight schedules, and what you get is one of the most complex operations anywhere on Earth. The margin for error is razor thin. A tiny delay somewhere can snowball into a massive problem somewhere else. So why is this so unbelievably hard to manage? It's not just about having a lot of people in one place. From a systems engineering view, the Hajj is what's called a combinatorial optimization problem. And honestly, that's where the real headache is. Let me try and break that down. Think of it like this. Every single bus, every walking path, every schedule for a ritual, they're all connected. So a single group that's delayed by, say, just 15 minutes, well, that can create a ripple effect that causes a huge bottleneck hours later, impacting thousands of other people. The number of ways things can go right or wrong is just astronomical. It's way beyond what any person or even a team of people could possibly figure out on the fly. Okay, so with all this crazy complex planning, it all really comes down to managing one single critical risk, crowd density. And this number you see right here, 6 to 7 people per square meter, that is the danger zone. That's the tipping point. Because once you hit that density, something strange happens. A crowd can almost stop acting like a bunch of individuals making their own choices and start moving more like an unstable fluid, like a wave. And that's where things can get dangerous. Preventing that from ever happening is priority number one. Now, to be clear, Saudi authorities have invested a ton of resources in amazing infrastructure and high-tech monitoring systems. But for the most part, those systems are reactive. They're designed to spot congestion as it's forming and then respond. The real game changer isn't just reacting faster, it's being able to predict the problem before it even starts. This slide just lays it out perfectly. The way we do things now with classical computers is kind of like a maze runner. You try one path, hit a dead end, you have to back up, and then you try another. It's sequential. But a quantum-inspired approach, it's like having a map of the entire maze at once. It can see every passable path, every potential traffic jam, all at the same time. It's about predicting what's going to happen, not just reacting to what already did. Now, what's really cool is that this isn't just some wild theory. There's a really smart, practical plan in place to test and perfect these advanced algorithms long before they're ever used in an environment as important as the Hajj. This whole phased approach is it's brilliant. You start with something that's already incredibly complex, the daily traffic of a huge city like Riyadh, that gives you tons of real-world data to train the system. Then, you move on to planning logistics for NEOM, a city being built from scratch, which is perfect for perfecting predictive models. And only after the system has proven itself in those settings do you even think about applying it to the very unique, very high-stakes world of the holy sites. Okay, so we have all this mind-bending computation happening behind the scenes. What does that actually feel like for a pilgrim on the ground? Well, the whole point is that if it's done right, the technology should be completely invisible. This quote right here just nails it. The idea is to let the technology do all the heavy lifting, to shoulder that massive logistical burden so that the spiritual experience itself can feel smooth and effortless for the people who are there for that very reason. Right. So if the system is working perfectly, what's different? What does a pilgrim actually experience? It's all about making the journey safer, calmer, and more focused. So for instance, imagine you get a little notification on your phone that suggests you just wait 10 minutes before heading to the next ritual. You're not being told there's a problem. No, you're being guided to help prevent a problem from ever even forming. The sacred rituals, they stay exactly the same, but the journey between them becomes smoother, which lets people focus on what really matters, the spiritual meaning of it all. Okay, so getting this right for the Hajj would be a huge deal, obviously. But the story doesn't end there. The impact of this could be much, much bigger. Basically, the Hajj becomes the ultimate test case. If you can build a system that keeps millions of people safe and moving smoothly during the most complex human gathering on the planet, well, you've essentially created a blueprint. The same ideas could be used for all sorts of other massive challenges. And that really leaves us with this massive question. Think about it. From making traffic flow smoothly in our biggest megacities to coordinating huge disaster relief efforts, the lessons we learn from safeguarding this sacred journey could help build a safer and more efficient future for everyone. Solving this one problem isn't just about one event. It's about creating a blueprint for managing complexity on a global scale.